Hello students and welcome to this video. In this video, we will solve question number 261 to 270 of permutations and combinations. The link to download the PDF will be in description, as well as at the end I will show you how we can download the other books as well. So without further ado, let's get started. Question 261 says that show that the number of permutations of n different objects not taken not more than r at a time when each object may be repeated any number of times is n multiplied by n to the power r minus 1 divided by n minus 1. So you have to understand here that repetition is allowed. So number of ways of taking one object at a time. We have to take in not more than r. So we take 1. So number of ways would be n. For 2 things, it would be n square. For 3 things, it would be n cube, and so on. So total number of ways for r things would be n to the power r. Therefore, total number of ways would be sum of all this, n plus n square plus n cube up to n to the power r, which is a geometric progression series, and the sum would be n multiplied by n to the power r minus 1 divided by n minus 1. Question 262 says that how many different 7-digit numbers are there whose digits is even, sum of whose digits is even. So smallest 7-digit number we know is 1 million, and the largest would be 9,999,999. So total number of 7 digits would be, total number of 7-digit numbers would be 9 million, and half of these will have even sum and half will have odd. So that is 4.5 million. So if you don't know million, million is 10 lakhs. So 1 million is 10 lakhs, 9 million is 99 lakhs. So this is 99 lakhs, 99,999. Question 263 says that k numbers are chosen, spelling mistake is here, with replacement from the numbers 1 through n. So k numbers are chosen with replacement. Find the number of ways of choosing the numbers so that maximum number chosen is exactly r. So we can choose k numbers out of r in r to the power k ways because numbers can be replaced. However, r minus k to the power k will not have r as maximum. Therefore, required answer is r to the power k minus r minus 1 to the power k. So if you choose, say, one number here out of r, that is r ways. If you choose 2, it would be r to the power k. If you choose r minus 1, that would be r minus 1 to the power k. But that won't contain r, right, as maximum. That is not the maximum. So that is r minus k to the power, r minus 1 to the power k. That's what we have got here. Question 264 says that find the number of n-digit numbers formed with the digits 1, 2, 3 through 9 in which no 2 consecutive digits repeat. So number of ways of filling most significant digits is 9, 1 through 9. Okay, so 9 digits are here. So most significant digit can be filled in 9 ways. Now next position can be filled by any digit which has not occurred at the most significant digit. Say you place 1 at the most significant digit, then the next digit cannot be 1. So we will have 8 ways. Suppose we chose 2. Then at the next digit we can put 1 but not 2. So consecutive digits cannot be same. So it will be always 8 after the first position. So required number is 9 multiplied by 8 to the power n minus 1. Question 265 says that a valid Fortran identifier consists of a string of 1 to 6 alphanumeric characters which are A through Z and 1 through 9 beginning with the letter. How many valid Fortran identifiers are there? So identifier is basically a word. It's a variable name in programming. Okay, identifier. So it is, you can assume that it is basically a word. and we can use A through Z and 1 through 9. So there can be 1 to 6 alphanumeric characters. First one has to be letter, that is A through Z. So first position can be filled in 26 ways, and all remaining positions can be filled in 36 ways. But the identifier or the word can be of up to 6 characters. Okay, it says 1 to 6. So if it is of 1 character, number of ways would be 26. Excuse me. If it is of 2 characters, then first character can be filled in 26 ways, second can be in 36. So 26 multiplied by 36. If it is of 3 characters, first one can be filled in 26 ways, next 2 in 36 ways each, so 36 square. And for 3 it will be, for 4 it will be cube, for 4 characters cube, for 5 characters to the power 4, and for 6 characters it will be to the power 6. So 26 we can take common, and then it will become a geometric progression, and we have the sum as 26 multiplied by 36 to the power 6 minus 1 by 35 divided by 35. Question 266 says that find the number of 5-digit number which can be made with at least one repeated digit. So we can fill the 10,000th place in 5-digit number in 9 ways. Rest of the position can be filled in 10 ways. The total number of 5-digit numbers is 9 to the power 9 multiplied by 10 to the power 4, that is 90,000. However, these numbers will include numbers without repetition. So we compute numbers with repetition. Now, numbers without repetition is, okay, there is something wrong here. So this is numbers with repetition, but it is all the numbers we have. So it will also include numbers without repetition. Okay. So numbers without repetition is, for the 10,000 place 9 ways, for thousands place again 9, which will include 0, but not the 10,000th digit, and then multiplied by 8, multiplied by 7, multiplied by 6. So we have 27,216. The number of numbers with repetition is 90,000 minus 27,216, which is 62,784. Question 267 says that find the number of numbers between 20,000 and 60,000 having sum of digits even. So total number between 20,000 and 60,000 is 40,000. Half of these would have sum of digits as even, which is 20,000. Question 268 says that find the wrong space. Find the number of ways in which the candidates A1 through A10 can be ranked if part A, A1 and A2 are next to each other, B, A1 is always above A2. So we treat A1 and A2 as one entity. Total number of arranging all the candidates, right? Candidates is 9 factorial, but A1 A2 can be arranged in 2 factorial ways. So total number of ways in which A1 and A2 are together is 9 factorial multiplied by 2 factorial. Total number of permutations is 10 factorial. In half of these, A1 will be above A2, thus required numbers is 10 factorial by 2 factorial. Question 269 says that m plus n chairs are placed in a line. You have to seat n men and n women on these chairs so that no man gets a seat between 2 women. In how many ways can these people be seated? So no man can sit between 2 women, therefore all men have to sit together. Now we treat all men as one man. Number of seating them together would be m plus 1 factorial. M is the number of women and 1 man. We are treating all men as 1, so m plus 1 factorial. However, n men can be arranged in n factorial among themselves. So total number of ways of seating them is m plus 1 factorial multiplied by n factorial. Question 270 says that how many words can be made with the letters of the word intermediate if no vowel is between 2 consonants? So we have 2 I's, 2 T's, and 3 E's, and the rest of characters occur once. So since we are given that vowels cannot be between consonants, the vowels have to come together. Now we treat all vowels as 1. So we have how many vowels? two I's and three E's. So 5. And then we have A, and so 2 and 3, 5. Intermediate. Okay, 3 I's, 2 I, A. This should be 6, right? Okay, so we treat all vowels as, okay, we treat all vowels as one character. So total number of characters is 7 because we have 6 consonants. So total number of ways to arrange them is 7 factorial by 2 factorial because 2 T's are here. So 2 factorial we have to divide by. Now 6 vowels can be arranged among themselves in 6 factorial by 2 factorial multiplied by 3 factorial because we have 2 I's and 3 E's. So 2 factorial and 3 factorial will be in denominator. So desired number of words is multiplication of these two, that is 7 factorial multiplied by 6 factorial divided by 2 factorial multiplied by 2 factorial multiplied by 3 factorial, that is 151,200. So with this we come to the end of this video, and I will show you how you can download the remaining books. So you come to my website ashtavakra.org. You can download algebra, trigonometry and coordinate from second, third and fourth link. So note that there will be lots of typing mistakes and I'm fixing those, and in a manner these are good. I mean, typing mistakes are good because you have to be careful that while reading, particularly with answers, these are good. It is not good in questions, but in answer, typing mistakes are good because you have to be careful. You simply just can't copy it. So with this, I will end this video here. I hope that you have enjoyed this video and found it useful. Thanks a lot for watching the video, and we will meet tomorrow again with 10 more problems on permutation and combinations. So I'll take my leave here and I'll see you in the next one. Enjoy.